Oh, that's my head and sword.
That's gonna get yours then.
I'm gonna be a
So, this is my new camera I just purchased for Christmas. So,
sword. You're gonna see me in Hollywood pretty soon. After my debut and swords.
Aren't you afraid it's gonna be too zoomed out?
no, that, trust me, I can see an ant with that lens.
Wow.
I zoomed in pretty far. I have a 300mm lens, but I put it on there, and I literally could see, like, there's a black speck on that marker board. It was so zoomed in, I could see that speck, like, full blown. And I couldn't zoom out further. That's where it started. So, I had to pick a wide angle lens.
Sitting there. Well, you start here. Huh? Jackie, you right there? I know I was
T.O.,
you missed it.
I know. Hey, you missed the Bills party. Kyle won a 20-pound bag of birdseed.
Guess what?
What?
Derek got a mug.
Wait, why didn't I get a gift?
Stewie got a mug.
I feel left out.
There was an extra present, but you went there to open it. So Derek got it.
I got some weird like clown thing.
Yeah.
So
he
that's
got
like chilling in the car.
like statue thing.
Who did this? Somebody else?
No, it was
Daniel back.
Who?
Nick says
Because Eric was gone.
Wow,
It's
that's
like
like,
you
there's
picked
like
the
two
card,
numbers for
and
like your
a card had a bumpers on it, and then you had to match the
I
numbers.
know it's hard to
card.
play. I heard Eric's retiring.
He is.
If you cast your
He's
game.
making it through the year though.
It's not what I
Yeah.
studied.
Wait,
so I said like five or something like
Alright.
choice equations and ABCD, and it was like you gotta like balance like react.
Okay, hey, just let you know, at some point, okay, some point tonight, tonight or tomorrow morning, I'm going to post video for today's lesson. I do have going on 2 different cameras today to kind of see which one you guys prefer in the back. So I got a like full-blown deal. Oh, 6.
I think
So,
I'm on TV.
so I'm going to see which one I like. So I got my DSLR in the back, got my GoPro in the front. We'll see which one gives you the better real estate for the board, which one's clear. No. So I just want to try it out and see which one we kind of like. I don't know which one has a better microphone either. Right now the GoPro is kind of weak. That's why I always do recording on my MacBook. But we'll kind of see how that goes. That's my new purchase for Christmas. So we'll see if we like it. I'm going to use it for sports anyway. But I thought, you know, might as well use it for a classroom if it looks better than GoPro. So we'll see.
Cool.
I like that one more already.
Don't know how it's going to look.
Skills.
And I don't know how long it records for either.
Can you see the board? Like
Yeah, I'm pretty zoomed in.
You can watch the video and then like zoom in on kids.
with your hand up all the time.
Yeah. All right. Okay. Hey, let's continue on here today. The section we're in section 2.6. These are called rational functions. Basically, what we talked about Friday was we did kind of a review of the homework. You know, finding roots. What happens when I give you the root? Can you make your polynomial from that? We did some review. So if you were gone Friday, we did have page 336 due. So try and get that turned in. But today we're going to continue on with the topic that we talked about last Wednesday, Thursday, rational functions. My goal today is to try to wrap it up. Try to finish off the last couple of problems on this, make sure that you know how to do it, you feel comfortable with it. It's back into graphing. So that's what we'll continue. I believe the video from Friday's lesson will be online, hopefully this morning. I think it's already posted, so I'll make sure it's on the website before you guys leave today. And then Thursday's lesson, remember the sub was here, so that doesn't have a video, so you'll have to watch Friday's or Wednesdays to get kind of notes from there. Question?
What are we going to test out of this?
Probably, like, I'm thinking maybe Tuesday or Wednesday next week. The reason why we only have like 1 or 2 sections left, and I want to make sure that we do a full two-day review. So I'll kind of look at the sections we have left. I think we're like 1 or 2 sections out. So we're almost done. So that's, I want to take it before Christmas break so we don't have to worry about it. It's not going to be like super difficult. It's just going to be kind of the basic problems. If you don't know what we've talked about, polynomials, you know, how to abstract them, how to find the roots, how to graph those, that's basically it. So, I mean, it's not difficult stuff. It's just we've done a lot of things with it. We'll altogether. We still have a couple more sections to go here, like what I want to cover.
So then on Thursday, can we watch the movie?
We'll see.
Come on, Lord. I'm dying.
That'd be cool.
We might play.
Oh.
All right.
Christmas competition.
All right.
Winner gets
All right.
the GoPro.
Let's talk, no. All right. All right. Let's talk about rational functions. Okay. So what we're going to talk about today is we're basically going to cover how to graph today. So I want to make sure that we cover those main topics. Like for instance, for graphing, we talked about one of our main topics we definitely talked about was the end behavior. That kind of gives us a glance of how end behavior works. I'll talk about like where that fails sometimes. One of the main topics we need to talk about today is x and y intercepts. We'll talk about that today. And then symmetry. That's kind of a big deal today. See if things are symmetric. You can basically figure out symmetry from right away from the original problem because of the way that the x-intercepts fall. Like, are they perfectly balanced across the x and y or the y-axis? That type of thing. So that kind of tells you. And then the big goal today, like what we're going to spend probably the most time on today anyway, will be the idea of the asymptotes. We talked about vertical versus horizontal. That was our topic last week. Vertical versus horizontal. And then we also had that one called slant. Okay, that's what we're going to talk about today. And we really need to cover vertical. Hopefully those make sense. There's one topic we need to cover there. Horizontal is our main like chunk. We need to focus on. There's 3 rules for that. I want to make sure that you know your rules, and there's this weird situation that can happen with those. They're not like vertical. Horizontal, they're kind of special in a way. And then slant was one that I think we talked about Wednesday last week, for sure. All right, so does everyone kind of know our goal? This is kind of our goal. We're going to spend the most time on that. If we have any time left over today, which I don't think so, we're going to spend the most time doing that. We're just doing notes today. I do want to, if we have some time, I do want to cover limits one more time to talk about that. Because that was a topic that we definitely discussed about a week or so ago when we were talking about how can we find those peaks and valleys when we did the differential quotient. We're not going to do something that difficult today. It's just, I want to talk about an idea behind it. So that's what we're going to discuss. And it actually goes really well with the vertical and horizontal. Okay, questions, comments about kind of our goals today? Okay. We're not going to do any problems. I have maybe 2 or 3 picked out that I want to do from the book. Just kind of make sure that you kind of know it. It's kind of one of every type. And then we'll kind of see where we're at. Okay, so we'll start with the first one. I'm just kind of picking from the book here. I'll just add one of the 3 out here. Start with this one. Yeah, 52.
F of x equals 4x over x squared minus 1.
Okay. All right, you if you want. Okay. So this is my function, right? It's rational. It's a fraction. That's what rational means. It's not a polynomial, obviously. So we can't do like the typical stuff like end behavior right away. Can't figure out symmetry and stuff like that. We can do like little things every now and then. For instance, like symmetry, the end behavior won't make sense on this problem. The reason why is that taking the top divided by the bottom, for the powers, the greatest powers, you get a fraction, like you get a negative. So it doesn't make sense where the end behavior goes. That's kind of a rarity. Usually, like end behavior tells you like when you take the top greatest thing divided by the bottom greatest thing, you look at the power, and if the power's odd, the tails go different directions. If the power's even, it goes in the same direction. But this one you get a negative, right? If I take the top item, there's an x to the first, right? And I take it divided by the bottom thing, you get 1 over x to the first, right? Because you take away 1 of the x's from the top, take away 1 from the bottom, and this is what we're left with. That doesn't make any sense for end behavior. Okay? The only thing I can tell you is what is the power of the x? 1. So probably what's happening. The tails are probably not going the same direction, but it doesn't make sense in terms of that degree thing because we've never dealt with negative powers before. So that's just something. So like talking about end behavior, sometimes that rule doesn't apply because it doesn't make sense. All right, questions, comments about end behavior and the idea of like what I look for, like the common sense rule that I always check. Okay, it doesn't make sense in this one. This is the way the powers work. The one thing we can do though, we can figure out x-intercepts. X-intercepts, or what we call the roots, or zeros. Right? We've also talked about instead of the roots or x-intercepts or zeros, it is kind of like the idea of domain, right? Like what x numbers you can actually use, that type of thing. Now, for x-intercepts, right? Typically, what happens here is it's something like this, where you have some x number and then the y number is like 0, right? So that's like the big idea. So this is like the common sense thing I always think of. Like, I want to make sure that my y turns out to be a 0. So for that to work for an x-intercept, whatever this number is, for the y to turn out to be 0 in this problem, basically I need the top number to turn out to be 0. If that turns out to be 0 up here, then the whole fraction is 0, and that makes y equal 0. Because remember, this stands for y equals 0. Right? So what's the one number that makes the top of this fraction 0? 0. That's your x-intercept. It's 0, 0. Okay, it's x equals 0. That's the only number that would make the top 0. So we're going to definitely hit the x-axis right here. In fact, what also do you know about that? It's also y. It's also y. So that's something you need to realize. Okay, it's the same. It's the x and y intercept on this particular problem. Typically that doesn't happen. Sometimes you always have to factor the top apart to see kind of what makes the top 0. So there might be a couple different numbers. So this problem right now actually has potential, because that's my x and y intercept. It actually does have potential to be symmetric. So you need to realize it does have potential to be symmetric across the x or across the y-axis. Because since that's right in the middle, it could probably do the same thing right and left if there could be something going on. In fact, to prove symmetry, because we already found the x and y intercept, to prove that it is symmetric, what was the rule that we always do for symmetry? Yeah, you plug in a negative x into this problem, right? So I take this and I plug in the negative x, right? The bottom, when I plug in the negative x, the bottom, the power 2 cancel out the negative sign, which is good. And then the top, the negative sign actually sticks around. In fact, correct? Like it's negative 4x. The negative sign on the top can actually go out front. Because it doesn't matter where you put the negative sign, if you put it on the top or bottom, it's still negative, right? Well, what this is telling you, when you look at that, it is the opposite of the original thing you started with. That's the idea. Because the negative sign doesn't matter if you put it on the top or the front. It's the opposite of that thing. So if it's the negative of the original item, that means this is odd symmetric. It's the perfect opposite of the original item. Because it's negative of the original. Because I can factor out the negative sign. Because that's what this one is. I can pull the negative sign out front to here. Does it make sense to go to the top first? Okay, does that make sense for odd symmetry? We haven't seen that yet. That's why I kind of want to talk about this problem today. So it is odd symmetric. So what odd symmetry means is that something will happen over here, and it will happen up here the exact opposite. Or if it's up here, it will go down there. So it is perfectly symmetrical in this problem. We haven't seen one of those yet. Okay, questions, comments, concerns, what we've done here. All right. So that's my symmetry test. So this is an odd symmetric problem. Okay, next, now that we've went through the basic checks, we figured out x-intercepts, y-intercepts, we figured out the end behavior roughly, figured out symmetry, that it is in fact symmetric. Now we got to go to the asymptotes. Now we can go from there, we can start graphing this thing. Okay, so the asymptotes, let's do vertical first. That's one of the topics we talked about last week. For vertical asymptotes, you have to make sure that whatever numbers make the bottom 0, those are where the asymptotes are. Because that's an undefined point. That's what a vertical represents. So we need to factor the bottom part. So how do you factor that bottom? What rule is that? Is it trinomial? Is it common factors? Is it difference of squares? Cube rule or grouping? Difference of squares, right? So difference of squares, we do 2 parentheses, plus, minus. You break up the x evenly. You break up the 1 to be 1 and 1. And what are the 2 numbers that make the bottom zeros? What makes this 0? Be 1. What makes that 0? Positive, right? Those are where that's where my vertical asymptotes are. So what a vertical asymptote is, if you don't know, it's a point of undefined where the graph cannot cross it. Those are very strict. You can never cross a vertical asymptote, ever. So the idea is that there is 2 of those. There's one at -1 here. And there's one at positive. And again, those are imaginary lines. Sometimes some graphing calculators actually draw those in for you, like the older models, which I always find kind of funny, that when you go to the newer models, they don't do that anymore. So it kind of just like a step backwards, which I find kind of weird. So those are the vertical asymptotes. Does everyone understand how I found those? The bottom has to be factorable. Now, if you can't factor the bottom, and it's like, it's a square term, you could always do the quadratic equation to figure out what they are, to see if they're imaginary or not. Because they could be decimals. And/or you could do the rational test, like the homework that you just did, where you figured out numbers that possibly work, you take the back number or the front number. You could do that just for the denominator and figure out what numbers, like what whole numbers actually make that bottom 0. You can check those. That's why we did all that work on the front. Okay, now, how many vertical asymptotes do I have on this problem? 2, right? Now, do you see that there is a gap in between them? There is going to be a picture there, since there's a dot there. So there's some type of picture squeezed in between the vertical asymptotes. And here's the other groupie part. Since there's 2 vertical asymptotes, there's also pictures on the outsides of them. So how many total pictures am I going to have here? 3. There's going to be 3 pictures. For every vertical asymptote you have, there's always one more picture than that. What I mean by that is we said there was 2 vertical asymptotes. So there's going to be one more than that for pictures, like graphs. So this will have 3 individual graphs. One graph will be over here, a graph will be in the middle, there'll be a graph on this side. There's always a graph on both sides of the vertical asymptote. So if there's one vertical asymptote, there's 2 pictures, one on each side of it. There's 3, then there's 3 vertical asymptotes, and there's another one. There'll be 1, 2, 3, 4 pictures. There's always ones in between. That's what you need to realize. So I know there's 3 individual pictures here, and they are symmetric. All right, questions, comments about vertical. They're very rigid, very, very straightforward. Now, on to horizontal. Okay, all right, so for horizontal asymptotes, these are not so rigid, which is kind of weird. It's more of a guideline than anything. It kind of gives you a sense for where the graphs are kind of limited to. Horizontal asymptotes, there doesn't have to be any per graph. There could be one at most. There can be one horizontal, but it's not as rigid as the vertical. Vertical, nothing can cross them ever. Horizontal just kind of gives you a guideline. It's really more of like this idea of what a limit is, and I'll talk about it here in a minute. Okay, now there's 3 rules for horizontals. Okay, if the power on the top of your problem, so what's the highest degree on the top of my fraction? 1. If that is bigger than the bottom, so if this power is somehow bigger than the bottom, there's no horizontal asymptote. So now, is that the case in mine? No. So we do have it. We do have one horizontal. We have to figure out where. Now, if the top power is exactly the same as the bottom, we'll see that one here in the next example. Then what you do is you divide the leading coefficient. You divide this number by that number. So if this was like power 2, like 4x squared, you take 4 divided by the number in front of my x squared term here, so it's 1. 4 divided by 1, that's where the horizontal will be. Now, we don't have it. The powers are not the same. Since the top power is smaller than the bottom, agree? Since the top power is smaller than the bottom, that means you will have a horizontal asymptote right here. It's right at 0. Now you're probably wondering, okay, so there's a horizontal asymptote at 0. But what did we just say a little bit ago about my x-intercept? 0. Now isn't that weird? It hit 0. It did hit 0. But the horizontal asymptote is going right through it. This is the weird thing about horizontals. It's a guideline. Okay? It gives you a guide for where the graph is going to be kind of centered over. It's kind of like, I consider it like a center line. So that something's happening above and below it. Okay? The weird thing is graphs can actually pass through a horizontal. They can actually pass through this. And that's actually what you're going to see here. This graph is going to go somewhere through it. But then on the outside, what happens usually is when you start drawing curves and stuff, they get really close and sometimes they curve around it, but then eventually they hug against it. So what's happening here is probably my graph will hug against one of these horizontals. It could pass through it, but it will go right against it as they go left or right. So I'll show you that here in a minute. So it's more of a guideline. So that's the hard part about horizontals. Okay, so there's those 3 rules. Since my top is smaller than the bottom, we do have a horizontal line of 0. And it's just a guideline. Okay, now slant. For slant, that's where we could have an asymptote that's at an angle. That only occurs when the top power is bigger than the bottom. Now, is my top power bigger than the bottom power? No. So we don't have it on this one. And the other case for slant is that the top power had to be bigger than the bottom by only 1. So, like, if the top power was, let's say this is a 3, and that's a 2, that's when you could have a slant asymptote. Top power has to be bigger than the bottom by 1, not more than that. So I have no slant. So this one does have a horizontal at 0. Because the top power is smaller than the bottom. I should say instead of saying power, degree. That's the better term I should be using. And, numerator versus denominator. We use vocabulary. Okay, questions, comments about what we've done here, all these checks we've done. Now, the last step, okay, because obviously these are a little weird, to figure out where to graph these things. Because obviously, I really haven't filled in anything yet. I basically filled in my intercepts, I figured out where the asymptotes kind of go. This is where we're going to use this concept of what a limit is. Basically what I do is I'm going to plug a couple numbers over here, 1 or 2 or 3 numbers over here, kind of get a sense for where this graph is going. It's going to give me a rough sketch. Then I'll plug a couple numbers in the middle, and then I'll plug a couple numbers on the right side, over here. And I'm going to get a sense for where this thing is going. Okay? So what I'm betting on, there'll be probably some picture over here, some picture in the middle going up and down, and there'll be some picture over here, and maybe it's over here somewhere. But they're going to be perfectly symmetrical from each other. Okay, so let's plug a couple numbers. So somebody give me a couple numbers over here to plug in. Give me like 2 over here.
-3.
Okay, -7, where's that number? -7 is like right here, -3, and -3 right here. And give me another number.
Oh, way out there.
Let's go like 12. Let's go make it 12. I want to get at least a sense for where this thing's going. Maybe it's going down, maybe it's going up. I want to get a sense. And this is where you want to use your calculator. So does everyone have a calculator right now? We're just going to plug these numbers in and graph where that dot's going. Okay? So this is getting a sense for scaling. Again, this is roughly, and what we're doing here is we're doing a limit. Okay? What I mean by a limit, we're going to plug in numbers. So we're plugging a limit where x is approaching this vertical asymptote. Okay, this vertical asymptote is going through what number again? Okay, we're approaching -1, right? That's the number we're approaching. We're approaching it from the left side. You agree that's the left side? My left hand. And we're approaching it from the left side. How we denote left side? We put a little negative sign on the back of it, which is really weird. We put it up in the power. So we're approaching -1 from the left, and we're going to plug a couple numbers into this function. That's what we're doing. Okay, does that make sense for a limit? I'm getting a sense for, as we get really, really close to this -1 on the left side, what this graph is doing. And that's what a limit does. Now to do that, this is where you need your calculator. We're going to take a couple of these numbers and we're going to plug it into this thing. So let's try the -12 first. So we're taking this function and we're going to plug in -12 into it. And we're plugging the -12 into both spots. And make sure you're using parentheses and powers and all that good stuff. I'm plugging -12. So what this turns out to be, turns out to be a -48 divided by, that's 144, because that's -12 squared, is 144 minus 1, which is 143. And on a calculator, what is that? -1 point, or negative point, .3. Okay, so at -12 here, I'm at -0.3. That's right here. So -12, -0.3. Okay, so it's really hugging this horizontal asymptote. Okay, now let's plug in -7. So we're going to take out the -12 here in your calculator, plug in a -7, and let's try what that gives me. It should give me a -28 over, that's 49 minus 1, which is 48. And so now that's at -1/2. Something like that. Okay. And so it looks like it's kind of going down just a hair. Well, let's plug in -3 now. -3, so this turns out to be -12 divided by, that's 9 minus 1, which is 8. So now we're at negative, what is that, 1 and something, 1.5 roughly. So probably what's happening here is it's doing something like this. So we're getting really close, and this thing seems like it's going down. And if you want to prove the point, plug in, if you want to see that it is actually doing this, plug in like -1.5, where we're getting super close to -1, -1.5 here, and I'll prove my point that it's going to go down really, really far probably. So what do you get when you plug in -1.5 into that? Going down as we go. So it's going down and down and down. So as you can tell, like for the horizontal asymptote, it was giving me a sense where I knew at some point we're going to hug against it. That's what a horizontal does. It tells me my graph will hug against it. And then when it gets to the vertical, it's got to go. Whatever direction it's going. If it's going down forever. So as we're approaching -1 on the left side, this thing was approaching. It was going towards what numbers? Where was it heading towards? As I was approaching -1 on the left. Where is it going towards? Negative infinity. This thing is approaching negative infinity on the left. That's what's happening. It's going down to really, really small negative numbers. Like incredibly small. Negative infinity. Okay? Alright, so now what we need to do. We need to approach. Now what we're going to do is we're going to go through the middle now. So we're going to plug a couple numbers on the inside to see where this graph is going. So I'll plug in like -0.5, -0.5. We'll plug in +0.5. And we're going to get a sense for where this graph is going. So what I'm basically doing is I'm approaching 0. I'm approaching 0 from the right and the left. So positive from the right side and the left side. So let's plug in like -0.5 first. So we're going to do the left side of 0. -0.5 squared minus 1. Alright, so when I take 4 times -0.5, that's -2. And this number, 0.5 squared is 0.25, and I subtract 1, that's -0.75. And if I actually flip, that's positive 8 over, positive 8 over 3, which is 2 and 2/3. So 2 and So that's right there. And if I bet, if you take out the negative sign here, this will be a negative 2 and 2 thirds. Right there. So that means this graph is doing something like this. So it's going from positive to negative side. Is that what you guys were getting? Okay. So that's again, what I did there is I was approaching 0 from the right and the left. So I did the left first when I plugged in the negatives, and then now I plug in the positive numbers on the right side. Kind of see where this graph is going. And now what I'm going to do is on this side over here, I'm going to plug in a couple more numbers. Let's try like positive 3, we'll try positive 7, we'll try positive 12. So now what we're doing is we're approaching the positive 1 now from the right side. So this is positive 1, we're approaching from the right side. So we're coming in this way. We're going to see where this graph is going. Here's what I'm betting on. It's probably going to be something like this. Because what did we say about this graph earlier? It's symmetric. So they have to be complete polar opposites. So that's what I got to make sure of. So when I plug in a 12 into this problem, like a positive 12, this is 4 times 12, 144 minus 1, and that's 48 over 143, and sure enough, it turns out to be that 0.3 number. So that's positive 0.3 number over here. Okay, over here. Then when I plug in 7, I get 28 over 48, and that's 0.5, positive 0.5, which is right about here. So it was going up. And as I plugged in like 3, so this was 12 divided by 8, which is 1 and 1.5. So 1.5, so it was going like this, it was going up, and now it's going up completely. So if I plug in like a number like, say I plug in a number like 2 or 1.5, that number keeps going up higher and higher and higher. Okay, do you see how this graph is working? It was perfectly symmetrical, the graph on the right and left side. And what I'm using here is called a limit. I'm using numbers in my calculator as I approach the left side of that horizontal, or the vertical asymptote, plugging numbers on the right side of the vertical asymptote, and kind of get a sense for where this graph is going. Is it going up? Is it going down? So as I approach 1 on the right side here, that's the positive side of 1. As I approach this number, where was it going towards? Positive infinity. This thing was going to hit positive infinity as I get closer and closer to 1 on the right side. That's how I knew that graph was going up. Because these numbers were getting bigger and bigger and bigger. That was the idea. Does everyone understand this notation, like the left and right side? It's just this little quirky thing. All I do is I just use a calculator. Most people don't even think about it. They just plug numbers in the calculator and kind of get a sense where this graph is going, and they draw a rough sketch. But notice, how many pictures did I have? 3. There's 3 individual pictures, and they had to be perfectly symmetrical, like odd symmetric. So as the left and right side of the y-axis, the numbers are complete polar opposites. Negatives, positives, positives, negatives. They're complete opposites across the y-axis. That was the idea. Now again, the horizontal asymptote is just a rough drawing. It's a rough sketch. Okay? That graph could have easily crossed it. You know, this thing could cross it over here, and this thing could cross it going down that way. Because the horizontals are not like rigid. They're not as rigid as vertical. They're just a guideline where you're going to be going towards. And we roughly said the tails are going to move kind of like opposite directions. Kind of what's happening, kind of in different directions. But it doesn't make sense because having negative didn't make sense. That's why these things kind of flat out. All right. Questions, comments about what we did? Let's do one more. This will be our last run with it. I'm not going to spend as much time on this one. This one I spent a lot of time just to make sure that we know how to graph. We're going to go through this next one pretty quick. Okay? We're going to do one where maybe the powers are the exact same. Powers will be the exact same with my function. So we can graph this. All right. So powers, go through there, pick any problem from like kind of this section. Pick one where the power powers are the same for like the top and bottom degree. Okay?
Got it.
I don't know which one works, but just pick one of them.
F of x
Okay.
equals 3x over x minus 1.
Alright, perfect. Okay, the powers are the same, right? So this is the other rare case for the horizontal. Okay. All right. So first and foremost, end behavior. When you divide these things, it doesn't make sense because you won't get a positive number or negative. You get like literally like the number 1. So the tails are probably doing something weird, like they're flattening out. So that doesn't make any sense for end behavior because it did, like when I take the highest degree divided by the lowest degree on this, it didn't make any sense. So we're going to skip end behavior for right now, so they're probably flattening. X and Y intercepts. So let's do X intercepts first. What makes the top 0? 0. Okay, that's your X intercept for the top. So I'm hitting 0 on the X-axis. Okay. Okay, that's also a Y intercept. Okay. So it happened to be both. So we don't need to worry about going with the Y intercept since it was the same number. Okay. If let's say like I had to plug a 7 up here, then what I'd have to do to figure out Y intercepts, I'd have to plug 0 in all the X's to make sure that I can figure out the Y intercept. So I don't need to do that. So this is the X and Y intercept on this particular problem. Maybe tomorrow we'll do one where they have 2 different numbers. So you can see that. Okay, so this one also has potential to be symmetric. Agreed? Okay. So let's plug in the negative X's. Let's see what happens here. Let's see kind of where this graph is going. So we have my x-intercepts already drawn. Now for symmetry, we have to plug in the negative x into this problem. So 3, negative x minus 1. The top turns out to be a negative 3x. The bottom turns out to be a negative x minus 1. So what happened here is that that the top turned, but then the bottom did too, and this doesn't work. Because if I try to factor out the negative sign out of the bottom, like this, it's not going to look the exact same, because these would cancel out. It won't look the exact same what we started with, and it won't be the exact opposite what we started with, because the opposite would be this. Negative sign on the top, the bottom stays the same. That would be a negative. So this is probably not symmetrical. So the right and left side won't look the same. That's what you need to realize. Because the way that this worked out, where it wasn't the exact same, and it wasn't the exact opposite. And opposite means just the top is negative. So this is definitely not symmetrical. Okay, so now we go to asymptotes. What makes the bottom 0? So we're going vertical asymptotes. And what makes the bottom 0? 1. Positive 1, right? So we know at positive 1 here, there is an asymptote. Okay, so how many pictures am I going to have here? 2 pictures. I have 1 vertical asymptote, I have 2 pictures, the right and left side of it. And that's why, right now, you can already tell that it's not symmetrical. The asymptote isn't in the middle. Okay, so we definitely have something weird going on. So it's definitely not symmetric. Okay, now horizontal, what we talked about, a horizontal asymptote. Is the top bigger than the bottom? No. For powers? No. So that means that we do have an asymptote here, horizontal at some time. Because if the top is bigger than the bottom, then there is none. But since the top is not bigger than the bottom, we do have one somewhere. Now, since the powers are the same, what you do is you take the leading numbers and you divide them. So what's the leading number out front here? 3. Divide by the leading number out there. So what's 3 divided by 1? 3. So that means there's going to be a horizontal at the number 3.
You get slants when the bigger one's on top?
Yes. The slant is when the top number is bigger than the bottom by 1. Okay? So I don't have that. Okay? And if the bottom is bigger, then it's automatically at 0, like we just did that last one. So we have one at 3 because, again, how we did that, we took the top leading number divided by the bottom leading number. That's how we figured out where that horizontal was. And again, that's a guideline. I can cross it. You need to realize that. Okay? All right, so now what we're going to do is we're going to approach the vertical asymptote from the left and right side to get a sense where this drawing is. And there's 2 drawings. What I'm betting on is probably going to be a drawing down here, and there's probably a drawing up here. That's probably what's happening. just so, because when there's two pictures, they're probably kind of plugging in this direction, especially where that dot's sitting. So let's do the limit as we approach the, as x approaches +1 from the left side, the negative side. So we're going to plug in a couple numbers, see where this thing's going. So let's plug in like -6, let's plug in -3, let's plug in a -1. Let's get a sense for where this thing's going. Let's plug in like half. Plug in a couple numbers. What I'm betting on is probably going to do something where it goes down. Something like that. Okay, so let's plug in this. Let's plug into this function. Plug in the -6 first. Okay, what happens here, that's a -18. And we're going to divide by a -7. And so this actually turns out to be +18/7, which is 2 point something? 2.5? 2.6? Okay, so at this side, I'm up here at 2.57. Okay. Now let's plug in a -3. Get a sense where this thing's going up or down. So that's -9 divided by -4. -9 divided by 4. That is almost what is that? Almost 1.5. Positive 1.5. Something like that. 2.25. Oh, it's getting smaller. Just by hair. By hair, it's getting smaller. Let's plug in -1 now. -1. -1. That's -3 over -2. That's 1.5. So that's right here. And probably if I put in 0.5 now, let's plug in +0.5. 5, that'll be a -0.5 on the bottom. And this turns out to be +1.5 on the top. That turns out to be -3. 1.5 divided by 0.5. So -3. So yeah, this thing's going like this. So it's hugging again. So as I was approaching the left side of that vertical axis, this thing is, it's heading towards -2. That's what's happening. Going down. So I kind of got a sense for where that thing was going. And then on the right side, we do the same thing. We'll plug in a couple numbers. As I was approaching from the right side over here, we'll plug in like 2, we'll plug in 5, we'll plug in 10. We'll kind of get a sense. What I'm betting on is it's probably doing something like this. That's what I'm betting on. That's where the graph's heading. Alright, we'll continue on. Remember, the goal is kind of, look at this. Today, make sure you look at the video online, maybe tomorrow or tonight. I want to get somebody that has a sense for how it looks.
Matt Heineman, and February Clevenger, please come to the office.
Come through, make sure you're
Sure. Hey, Jack. What are we doing English today? No.
You need a big book.
Yeah, you have lectures right now or like 15 minutes. What book? Your lit book? The one we always bring?
No, a big one.
What is not covered?
That's fine.
Doesn't matter.
I don't.
Everything's okay.
I don't even know when we're supposed to have covered.
Didn't say.
I shouldn't say. What are you using it for?
What?
I want to tell you something, but I didn't turn it in here.
Anna, I haven't done mine. It's almost done. It's just okay. Just so these journal. That's so nice. I'm expecting a lot to be done. Oh, are you?
Page you're over one. You're right where Anna's sitting. Anna's right where yours
Did we have a symmetry yet?
is. Yeah, a long time ago. So here it is.
No, this was mine. Okay. Yeah, and then I figured Abby sits there. No, Abby sits over here. That was enough. Oh, that's in here. I didn't do my headings.